Good morning, everyone. And I'm Silvia Mastrolembo, and from the University of Brescia, as we say in Italy. And this morning I'm going to show you the very first result of a study that we have just started to focus on in our university. It is related to a joint research effort and a collaboration between two different departments. Oh no, you can see. Okay, but you can give me a sign. I was talking by myself. Perfect. I don't know what to do.
Okay. Ah, you have. I see.
Because I can see my slides, but you can't.
Yeah, it's no problem.
It's always like this. Okay.
No. And maybe you can even make it larger.
Yeah.
Yes.
I'm sorry. I was just saying that this study has just started in our university. It is related to a collaboration between two different departments, the Department of Civil Engineering and Architecture and the Department of Information Engineering. And it is related to the development of a recommender system for supporting BIM-based design. And in particular, in this case, at this first attempt, we have started to develop the concept design of the architecture for a recommender system for the energy retrofitting use case. In particular, as I said, okay, we still have a lot of problems. The slide doesn't change. We can do that. With this maybe.
Yeah, you can go up and down here.
Okay.
Just use this. So it's page up.
Okay. As I've just said, our research group for this project is a multidisciplinary research group made of different experts with different expertise, and we are part of a laboratory that is called ELUXI in our university, which has a focus on digital innovation for energy-related topics. And in this case, as far as I'm concerned, have an expertise in bioimplementation in management processes, while other experts in this group have strong expertise in other key topics for this publication related, for example, to information processing systems and building energy modeling. So if you will have some specific question or want some specific details on these topics, we'll also get in contact with the main authors of this publication as well. I will first start with a brief description of the motivation behind this research, and I will show you the methodology that we are applying and the very first results obtained. And I will also state some limitations of the approach at present that, of course, have affected some of the research activities, but at the same time pave the way for future works and ideas. First of all, why are we working on this type of topics? So the development of a recommender system for BIM object-oriented design. Because when we talk about building information modeling, of course, we are talking about the development of an assembling of building components, virtually prototypes, and within a BIM environment, data exchanges has to be interoperable. So between BIM authoring tools and BIM authoring platforms and BIM tools, we have to guarantee the interoperability of data. And in order to do that, we need to work according to relevant purposes and uses. For that reason, we can define what a BIM use is, and of course it is a method in which BIM is applied in order to achieve one or more specific objectives. At present, a new acronym is emerging in the BIM world, let's say, that is related to the level of information need. I'm not going to talk in detail about that, but what is important to say is that the perspective is changing. So the role and the importance of starting from the related purposes and uses of BIM implementation has to guide and to drive the building information modeling phase. And so the development of BIM objects that should contain the relevant data that has to be consistent and reliable for specific use cases. What happens today at present in our everyday BIM practice? When we have to develop a building information model, we start from assembling BIM objects, as we said. They can be found in BIM authoring platforms. You can look for the by categories, and you can either use predefined BIM objects, but of course you can modify them or create new ones based on existing template. So we have in our BIM library predefined and user-defined objects. At the same time, we also have digital marketplaces available, as we all know, from which it is possible to download for free manufacturers' products with a certain level of information contained. They can be searched by categories or by file format, and so our BIM libraries in professionals' daily life is made of different types of objects: predefined, user-defined, and manufacturer-defined. In the worst case, they are used without any idea, let's say, about their effective informative content and how it could be used for achieving a specific objective. So we should start changing the perspective a little bit, as we said. So the idea from which we started is to put an additional layer to the selection and the use of these BIM objects for creating building information models, which is the use case. It's not something new at all, but it represents a new level in this workflow, we can say. And so in this idea, we have the building information model, which becomes, as it is, an information container, and the focus is on the reliability of the data that are contained in it in order to guarantee interoperable data flow that are reliable in terms of quantity, quality, and granularity. Yesterday in another presentation we were talking about BIM, building information models are dirty, let's say. I'm citing my colleague from Milano. So this topic has to be further investigated in this direction. But at the same time, we could do another step in relation to the development of BIM objects with an appropriate informative content. We could complement them with data coming from past design choices. And in this way, acquiring knowledge from both the informative content of BIM objects and past decisions, so past selections of BIM objects based on our information needs and based on our purposes and use cases, we could deliver an automatic personalized way to recommend users of BIM authoring platforms in the selection of the most appropriate BIM objects based on that information need. And this is the idea, the framework in which we started to move when we decided to start this project in the development of this recommender system. This is the experience that we had so far. First of all, we started from taking into account a very specific topic. So we decided to start from the building energy modeling purpose, and in particular, we considered the energy retrofitting use case as an example. In order to do that, we started considering a case study. It was related first of all to the work developed by master students, and then integrated. It was just the starting point of this idea, and we started considering 3 existing buildings that have to be retrofitted for energetical purposes, and at the same time we started analyzing, of course, the regulation for energy calculation, in particular the Italian one, and we wanted to evaluate if the BIM objects available, for example in digital marketplaces, were suitable for developing such type of analysis. In particular, what we wanted to do, we first of all developed a calculation model for standard energy calculations according to the Italian normative framework for energy saving, and we decided to use a very common digital marketplace, and we downloaded a very common, again, BIM objects. They are developed for this specific BIM purpose, so for energy retrofitting, and in particular for the Italian market. So the first step was just to evaluate if this kind of objects that are available in the market are able to support our purposes. And developing the calculation model, we discovered that, as it was easy to imagine, that some informative content was missing to support our objective. This was the starting point for the development, at least now at a conceptual level, of a web-based recommender system. Basically, it is where the free buildings we started to think about this possibility. We considered a multi-story residential building, an office building, and a single-family house. As you can see, first of all, we developed the building information model of the existing building. After that, based on the thermal parameters for energy evaluation as required by our normative text, we decided to select some objects that were available, as I said, in this digital marketplace by a global manufacturer, and we started to look at the informative content of this object. We decided then to use them and to test them for this purpose. For example, as I said, we developed this calculation model for the standard energy requirements according to our energy framework, and we started testing a bidirectional link between this calculation model and our building information models, where different options for energy retrofitting were performed. And we started a process of, let's say, data enrichment. So in order to evaluate all of these energy performance, I'm sorry for the Italian in this part of the slide, we noticed that objects that were developed with this specific purpose and for this specific Italian market were not able to support the calculation according to the national framework. So the data enrichment process gave us the opportunity to complete these objects with all the necessary information, and now this bidirectional workflow works. So this was the starting point. Actually, we thought that this type of knowledge that we developed in this first very basic example, as I said, could be the starting point for thinking about the possibility to evaluate a recommender system. Let's say, if we suggest to integrate the informative content for this specific use case, so another user after us could be supported with our previous experience in selecting the most appropriate BIM objects and knowing which type of parameters need to be added in order to use this object effectively for the same purpose and fulfilling the same parameters and normative framework. So we started to develop the conceptual version of this web portal in which the users could be guided to the selection of the most appropriate objects for multiple. We're thinking to use it giving the possibility to the web portal to get data from multiple data sources, so for example for multiple digital marketplaces. And this portal works based on intended use, so as we said, for example, the need for standard energy calculation, and based on design specifications, so the location of our building geometry as well, for example. So this works on getting knowledge from both the informative content of the multiple BIM libraries and, as I said, past user selections. So at this point, we have developed, as you can see, a very concept design of the architecture of this web portal, where we could imagine to have two main core services that are related not only to the recommender system, but also, for example, to the possibility to integrate our calculation model as a service of this web portal, and then other support services, for example, user registration, design registration, the data source registration to other BIM libraries, and as you can see, we imagine to communicate with external BIM libraries. And the database that is collecting all of this information, all this knowledge, has a structure, a model of data that contains so both the description of the different data sources that could we access in order to get the BIM objects, and the BIM objects, the description of these BIM objects. At the same time, the user, after the registration, could include the description also of his design design with information about the context, the location, the type of building, as we said. Then there is a part that is related to an expert of the domain that, of course, has to match the BIM use with the necessary attributes in order to guide the recommendation. The recommender system is, in our preliminary idea, a core system of this service of this portal, and we are thinking to develop it in order to deliver a ranked list of BIM objects that, based on the request expressed by the user, is able to identify, also looking at the description of the BIM objects and previous experience collected in the database, which BIM objects are the most appropriate for a future design work. So the recommender system is structured to work, let's say, in three main phases: the request of the user, for example, the designer, the processing phase, and the recommendation, the final recommendation. So we are thinking about the possibility to input, from the user can input his target design, so for example, the information, the description of his design, and at the same time, before selecting the object category, of course, as we said at the beginning, it should identify the intended use in order to have a first filter on the object category. When we select the object category, the processing phase will show us, first of all the designs of previous users that are similar to the one that we are submitting to analysis. He will find candidate BIM objects that could we use because they have been used in the past in design similar to the one we are describing in this case. Then we are going to filter the objects based, of course, on the intended use and the desired category. And then we order the filtered BIM objects based, for example, on the higher number of previous designs where they were used, and so which corresponds to a higher ranked. The recommendation, finally, as I said, is a ranked list of BIM objects from multiple data sources in order to support the user based on his inputs from the processing phase. And if we can imagine how the web portal could be used, we can, as I said at the beginning, select, after the selection of the intended use and category, and evaluate the list of ranked BIM objects, select one of the objects from this list, and at this point we could move to the other core service of the portal, which is the energy calculation service. In this case, the design data are integrated with the ones coming from the BIM objects selected, and we could start, for example, making some design optioneering based on the informative content contained. We could also think about a system that, in case of missing information, alerts the users about the need to integrate the informative content of the specific producer's manufacturer's objects with additional data based on the normative context. Of course, what I'm talking about is a very preliminary conceptual idea of the design for this, of the architecture for this recommender system. And we just started to evaluate the expert part, so let's say the association between the BIM use and the level of information need, with a focus on this energy retrofitting use case. And the limitation, of course, is that we are at the conceptual phase, and this is a conceptual approach, so we need a prototype version to be implemented and preliminary evaluated in order to effectively test the effectiveness of the approach. So future works will be related to that, to completing the design of the recommender system, including, first of all, the energy analysis purposes, and in future other use cases if the effectiveness have been demonstrated, at least on the first one. And then the development of a prototype version of this web portal will be organized in order to evaluate, for example, this type of recommendation against alternative approaches, and we will need to test this initial implementation on multiple projects and configurations, again, in order to evaluate the effectiveness of this recommendations generation approach. For further information, here are the contacts. Thank you.
Thanks for the very interesting presentation. It's really a hot topic. I've just got a question for the web portal. How as I understand, you're still in the conceptual phase. So how are you intending to implement this as a monolithic system or using microservices? And if you already know how, please tell me why you chose that way.
Yes, we are at conceptual level, and I'm scared I'm not really the right person to tell you more about the type of technology and systems. I'm focused most on the design of the motivation behind the processes to be implemented, but as far as the technologies, the technological part is concerned, unfortunately I have to ask to my colleagues for the details. I'm sorry.
Okay, no problem, thanks.
Thank you for the presentation. I know the limitation with the BIM library, especially...
I can't hear you, I'm sorry.
Thank you for the presentation. I know the limitation of using a BIM library, especially when you use IFC material to export it to energy retrofitted simulation. But have you looked at any current project? For example, I remember there's one project, material passport, the European material bank or material passport is an European project for BIM to create a material library. Have you looked at this effort and maybe you extend it a little bit to your, or related to your project maybe?
No, thank you, first of all, for this suggestion. I haven't looked yet at this project, but I know that from the last Horizon 2020 foundings, there are several projects working on the BIM to BAM workflow, and for sure someone is working on this type of analysis and maybe also to the development of recommender systems. Moreover, I know that there will be also another paper on this topic in the next session, I think, and we will have to integrate the efforts on this topic, but I haven't looked at this project yet. We had a past experience with the IFC-based workflows in this case. This is not the case of this application. We made other projects in relation to this as I said, BIM to BAM workflows and comparisons between different approaches. In particular, my colleagues Lavinia did this project, and in this case, we didn't want to take into account actually the IFC model, but the possibility to make some preliminary design optioneering decisions based on the objects that are available on the digital marketplace. But why? Actually, we started to think from the perspective of typical user, and we wanted to simulate the experience of a professional, let's say a practitioner, and so we started in this direction, but thank you, we will take into account.
I also have a question. Would you see the risk that your recommending system might recommend products of one individual manufacturer all the time, and of one individual manufacturer, let's say the Windows manufacturer, and your system always picks exactly one, and the other manufacturers get angry?
Yeah, I thought about that, in fact, also because maybe when we talked before about the ranked list, for example, one of the criteria could be the higher number of the past design where this object was used corresponds to a higher ranking position. So maybe if this, there is this risk, maybe some rules could be adopted in the recommender system in the part related to the expert domain, where the map between BIM uses and attributes is set to avoid this problem. The problem, in fact, is, as you say, as you saw during my presentation, we started selecting one manufacturer, but of course, we didn't take into account the others that are available in digital marketplaces. We took into account this because we had the possibility to use objects from our, developed for our market, so we wanted to evaluate this. But effectively, yes, maybe there is a part